So next, I'm going to start milling cycles overview. So in shop mill, we have different types of milling cycles, such as face milling, pocket milling, spigot milling, slot milling, thread milling, and engraving. We will see one by one. First of all, what is face milling? Face milling means, for example, you have a workpiece like this. So removing material from the top surface and make the top surface of the workpiece flat is what is called a face milling operation. So the use of face milling is to make the surface flat and improve the surface finish of this surface and convert the thickness of the work. For example, we have uh, say 10 workpieces. We have to convert uh, the thickness of all the workpieces should be same. So for that, we will be using face milling operation. So for example, you have so let's take one example. For example, you have one aluminum block like this. Okay, so just imagine the surface will be a rough surface. So first we will do the face milling operation and convert this rough surface into a smooth one. So this is the use of face milling operation. Then the second one is called pocket milling. So pocket milling means, again, you have a workpiece like this. Okay. So here it is having a cavity, a closed cavity. So we will make a closed cavity. That is what is called a pocket milling or pocket machining. So we have different types of closed cavities like a rectangular cavity, square cavity, circle, polygon. The use of pocket milling is in mold making, die manufacturing, fixture design, component housing, etc. Next is called as spigot milling. So spigot milling means this is the opposite of pocket. Okay, so for example, you have a workpiece like this. Okay, so on the top of this, having one raised portion like this. Okay, this is what is called a spigot milling. This is for alignment pins, locating features, and assembly components. Another one is called slot milling. So slot milling means we can create a groove. Slot milling, for example, like this. We can create a groove, curved groove, straight slot, keyway, T slot, circular slot, etc. Of the different types of slot. Then next will be the thread milling. From the name itself, you understand what is thread milling. To create internal or as well as external thread using thread mill cutter. And finally, engraving. What is engraving? Okay, on the surface of the workpiece, you can create a text or a logo or serial number, drawing. Okay, anything you can engrave on the top of the surface of the workpiece. This is what is called engraving. So if you are going to manufacture a part, let's say one practical example. If you are going to manufacture a particular part, so initially you have the workpiece, right, raw material, right? So the first process will be face milling. Okay, make the surface will be flat. Then after that, pocket milling, then slot milling, then thread milling, and finally engraving. So we will see one by one. Okay, first I'm going to start phase milling operation. Phase milling. So as I have already mentioned, phase milling means it is to make the top surface of this workpiece flat and change the thickness of the workpiece into the necessary thickness is what is called a phase milling operation. So for that we need a tool called a phase mill cutter. Phase mill cutter, or we can use end mill. So using end mill or phase mill cutter, we can remove the material on the top surface of the workpiece and make and ensure that the surface of the workpiece is flat or smooth. Here, let's see what are the parameters. So we will start from T, right? So similar to the previous examples we discussed. So T means tool name, right? Then D represents the cutting number. F means the feed in millimeter per minute. S means spindle speed and V means the cutting speed. So in processing, we have two options. One is roughing and the second one is finishing. So direction will be alternating or same direction, alternating or same processing direction. Then we have X0, Y0, Z0. This will be the uh, first corner point of the raw part. For example, this is your part. This will be X0, Y0, and Z0. Then X1, Y1, Z1. This will be the second corner. This will be the second corner of the finished area. And yeah, and next is DXY. This is maximum step over. DXY is maximum step over. DZ means maximum depth per pass. This is only for roughing. DZ is only for roughing, and UZ this is finishing pass depth. So when we see here processing, you have two options, right? One is roughing and finishing, right? What is the difference between roughing and finishing? Roughing means large amount of material will remove. Okay, milling will be happening in different passes. Surface finish may not be that much good in this roughing operation. Finishing means remove small amount of material, you will get better surface finish. Just a single pass is enough. In roughing, the tool will travel multiple passes, right? Like this. This is called a passes. But in finishing operation, it just a single pass is enough to finish it. Then we have direction. We have milling direction. So that means first, say tool will start from the left to right. Okay. Then from right to left. Okay. So it will take machine time will reduce. Okay. That is alternating processing direction. Same processing direction means all pass will be like this. So the surface finish will be more uniform in same processing direction. Coming to the workpiece coordinate system. Sorry, not coordinate system, workpiece coordinates. So so here in this picture, yeah, here you can see this point represents what? X0, Y0, and Z0. This will be the first corner point. Say X0, Y0, X0 will be 0, Y0 will be 0, but Z0 will be, what will be the thickness of this object? Say 25 millimeter. So 25 will be the Z. And then coming to X1, Y1, Z1. So this will be the final corner point. So this will be X1, Y1, Z1. Okay, so the meaning is that so X1, Y1, Z1. So here the thing is that here you know what is the size of what is the thickness of this object? 25, right? So what will be the dimension? 100 by 80, right? Say just take 100 by 80. So when you give Z1, you should give, so here what is here? This is X0, Y0, Z0, right? Here what is X0? Here X0 is equal to 0, Y0 is equal to 0, and Z0 is equal to 25. When reaches here, we should remove 5 mm thickness. So here you should give Z1 is equal to 20 mm. So that means uh, we will remove material 100 by 80 mm area face, okay, and reduce the thickness or height of this object from 25 mm to 20 millimeter. Then coming to dxy. So dxy means, for example, this is pass 1, pass 2, pass 3, pass 4, like that. Okay. So dxy means each pass. Okay. So how much distance the tool will move to the side? Okay. So for example, the tool diameter is 20. If the tool diameter is 20, okay, then dxy we can give us half of that 10 mm. So after each pass, this tool will shift to 10 mm. That is what is called a dxy. Then dz. So dz is equal to 2 mm. So that means in pass one, so total material will be say 6 mm. So dz will be 2 mm. So pass one, remove 2 mm material. Then second pass next to 2 mm. Then the third pass will be next to 2. So total 6 mm. Then uz means the finishing elements. Okay. So uz means finishing elements. That means some amount of material will be there for finishing. Okay. So that means after roughing, there will be 0.2 mm. So that material will remove here in this finishing pass depth. So 0.2 mm. So how this phase milling cycle is working? Okay, we will see. First of all, we have a retraction plane, right? Then we have a safe distance, right? Okay, so rapid traverse, that means G0 mode. Rapid traverse tool will come. Okay, so tool will come to the safe distance. Okay, starting position. Okay, say for example, starting from here. Okay, starting from here. Okay, if we selected a roughing, it will remove material in multiple passes. In finishing, the material will remove in one single pass. Finally, the tool will safely retract from the workpiece. Okay, next is what is called a boundary selection. Okay, so for example, you have this workpiece, right? So we should select the boundary. A machine don't know where is the boundary, how much distance I have to mill. So machine don't know. So we have to tell the machine, okay, this is the boundary. So that means left, right, bottom, left. Okay. So based on this selection, the tool will move and do the face milling operation. So let's take one example. You have a workpiece, say 120 by 80, and the thickness is say 25 mm. So the final height will be say 20 mm. So we need 20 mm thickness. So we can use T1 face mill, feed 500 mm per minute, spindle 1800 RPM. So processing, roughing plus finishing. Then X0, Y0, Z0 we can give X1, Y1, Z1. Then DZ is equal to 2 mm, UZ is equal to 0.2 mm, DXY is equal to 20 mm. So machine first through the roughing, remove the material. Then after that, 0.2 mm finishing pass will give the final surface finish. Okay, so we can try this in our machine. So go to program manager. Okay, go to program manager. So I'm going to create a new one. Okay, SHOPMILL. So 100, 100, 25, right? So 100, 125. So 100, 125. So let me see. 125. Okay, that's it. Okay, so here you have to select. Uh, so here go to offset, not offset. G58. There is no offset. So I will select it. So I will select unit of measurement as millimeter, and I'm selecting the work offset as G58, and it is a block, right? So it's 00, it's 100, 100. HA is top surface, HI is 24, retraction plane 25, and safe distance 2. Okay. So 2 retraction plane, machine sequence, this one, that's it. It's okay. Everything is okay. Okay, then go to mill. Okay, then I'm going to select face mill. Okay, so I'm going to select face mill. So I have selected this facing tool, right? Then feed how much you can give. Okay, let's say, okay, so tool I have selected. So tool, tool is facing tool, right? And then feed how much? 500 millimeter per minute. Okay. And then spindle speed, say 1800 RPM. Okay. So feed I will enter say 500 millimeter per minute. Then spindle speed say 1800 RPM. 1800 RPM. And machining, we have two options. One is roughing and the next one is finishing. Okay. So here I'm using roughing operation. Then after that, okay, then after that you have to enter. Okay, so of roughing operation, I selected roughing operation. Then roughing operation I have selected. Okay. So roughing operation I have selected. Okay, then uh, nothing operation, right? Then direction will be like this. So the tool will be going like this, or this one. Okay, so tool will come here, then go back, then again it will come here, then go back like that. So all the machining will be from left to right. That is called same machining direction. Then this one changing machining direction. So this will go like this, and then next one is this one. Okay, so this will go here, then go up, come here, then go up, come here, go up, come here, like that. So that is what is called direction. So right now I'm using this one. Okay, first one. Okay, no, this one I'm using. Okay, after this, go up, come here, like that. Okay. Okay, so then x0, where is x0, y0 is, sorry, z0 is what? Z0 is 25, right? So this is the, okay. So in our case, okay, so cancel, go to your program header, uh, do one thing. So refraction plane is 25. Okay, so in this case, I will change this to 30. So refraction plane, okay. Then go to mill, face milling. Okay, so facing tool I have selected 500, 1800 RPM, right? X0, Y0, Z0, say Z0 and say 25. Okay, and then X1, 100, 100, then Z1 is say 20, we need 20. Okay, so DXY, DXY is say, yeah, this is DXY, right? Say 20, then DZ2 mm. So DZ means so total, okay. So two, then you Z finishing allowance say 0.2 mm. Okay. Okay. Then after that face milling, machining operation, finishing operation. Okay. So this is 0 0. This is how much? This is 25, right? This is 25, 120 dx by 20. Okay, 0. Accept. Okay. So here you can see this represents this one triangle represents uh, cupping operation, and the three triangles represents finishing. Okay. So just go to execute. So let's raise it. Program manager. So program manager. Building cycle of simulation. Oh my God. What is called phase one. Okay, so next is a rectangular pocket. So this is your workpiece, right? So you have a cavity in the shape of rectangle or square. So now you are going to create this. This is what is called a rectangular pocket. Now you are going to create a rectangular or square cavity. And this milling operation is what is called a rectangular pocket milling. This is for mold and die manufacturing, fixture plates, housing components, electronic enclosures, mechanical parts, etc. So we will see the parameters. So T represents the tool name, D means cutting number, F will be the feed rate, S will be the spindle speed, and V means the cutting speed. Then we have a reference point, pocket reference point, then processing, roughing, finishing, edge finishing chamfer, then pocket reference coordinates, x0, y0, z0, and then W means width of the pocket and L means the pocket length. Then we have R. R represents the corner radius. Alpha 0 will be the pocket rotation angle. Z1 will be the pocket depth. Dxy will be the step over distance. Dz means maximum depth per pass. Uxy will be the side finishing allowance. And Uz will be the bottom finishing allowance. Okay, so coming to the reference point. So coming to the reference point, you can select the pocket reference, different options such as, so for example, this is your pocket, okay? So you can select the sender, okay? Pocket reference will be the sender, or bottom left, this one, or bottom right, this one will be the reference point. Then top left, this one, and top right. So these are the reference points. Then we have processing modes such as roughing, finishing, edge finishing, chamfer. So processing mode, you will select the roughing. Roughing means material will remove very quickly. Finishing means pocket wall, bottom, everything will be more smooth. So during the roughing operation, the finishing will be not that much good. Edge finishing means it will finish the side walls of the pocket. Okay, and if you have a chamfer, okay, in the pocket edge, this chamfer will create that chamfer on that pocket edge. Then pocket dimensions, what will be the width, length, and what will be the width, length, and corner radius. Rotation angle will be 30 degree. So Z1 will be the pocket depth. So minus 10 millimeter. Z1 will be the pocket depth minus 10 millimeter. Then we have roughing parameters dxy. Dxy is equal to 8 mm. Dz will be depth per pass, say 2 mm. And uxy will be the side finishing allowance, say 0.2 mm. And uz will be bottom finishing allowance, 0.1. Then plunge mode. So plunge mode means this mode will tell the tool, okay, how how the tool will enter into the workpiece. Okay, so you have different modes, such as one is called a vertical plunge mode. So vertical plunge mode means so the tool will directly enter into the workpiece. Helical plunge. So helical plunge means the next one is called a helical plunge. Helical plunge means the tool will follow a spiral path. And Another one is called a swinging plunge. So swinging plunge means like a back and forth movement. Then we have clearing modes. Okay, so complete processing, reworking. So complete processing means complete raw material will remove from the pocket. So reworking means partially before pocketing, partially machining material removal was there. So during this, it will enlarge. So machine will enlarge that pocket. That is called a reworking. That means a drilled hole is already available. If you have a drilled hole available, then you can use this reworking option. So AZ means the existing pocket depth, W1 existing pocket width, and L1 will be the existing pocket length. So if you use this reworking, you should give all these three values. What will be the existing depth, width, and length of the hole? Okay. So let's see. So let's take one example. So we have our workpiece. Okay. So we have our workpiece. Same. Now you know our workpiece is same 100 by 100 by 25, right? Okay. Then we have a pocket. Then we have a pocket of width 40, length 60, depth 8, and a corner radius 5. So tool, we can use a tool of 12 end mill. Then feed. So feed, say feed will be uh, so feed will be 300 millimeter per minute, and the spindle speed will be 2500 RPM, and reference will be the which one reference you will take a reference as the sender. Then after that, what will be the width, length, and radius? Then processing will be roughing plus finish, and plunge will be helical. So dz will be 2 mm, dxy will be 6 mm, uxy will be 0.2 mm, and uz will be 0.1 mm. So your plunge will be helical, right? So that means machine using the helical entry, it will enter into the pocket. Then 2 mm depth per pass. Finally, it will give 0.2 mm side allowance and 0.1 bottom allowance. That will give you a better surface finish to that pocket. So we will see this in our machine. So go to menu, select program manager. Okay, just open this. So pocket. Okay. So say field will be say 300 and then reference point will be center. Measurement will be roughly. Then single position. Then what will be the x0, y0, and z0. So x0 will be. So what will be the? So this one will be. 0 10 z0 x0 10 z0. So the positions are relative to the reference point. Seventh will be 40, right? Then ninth will be 60, right? And the 91st will be 5. One will be absolute, that means 8. That right? Reference point. Z is equal to 2, u x y 0.2, and u z 0.1. So we finished rectangular pocket. So next will be the circular pocket. Okay, so next will be the circular pocket. Here also, this will be like similar to pocket, but the shape of this will be like a circle. That's why it is what is called a circular pocket. Circular pocket. That means you have a workpiece, right? You have a workpiece, and inside the workpiece, you are going to create a round cavity. Create a round cavity is what is called a circular pocket. So the parameters will be similar to the previous one. T represents the tool name, D will be the cutting number, F represents the feed, right? S means spindle speed, V means constant cutting speed. Processing will be roughing, finishing, edge finishing, and chamfering. Processing type will be planar or helical. Then processing position, individual position template. Then where is the circular pocket center point, X0, Y0, Z0, center point of the circular point. This will be relative to the reference point, and phi will be the diameter of the pocket, and Z1 will be the pocket depth. Z1 will be the pocket depth, and dxy. So dxy will be the step over. Dxy will be the step over, right? Dz will be the depth per pass, and uxy and uz will be the finishing elements. Uxy will be the side finishing elements, and uz will be the bottom finishing elements. Fc will be the plunge feed. EP means helix pitch. ER will be the helix radius, and FS will be chamfer bevel width. AZ and phi 1 will be the details of the existing pocket or hole details for reworking, like I have discussed earlier. So in this case, check the processing type. We have planar. So planar means this will process layer by layer and clear the circular pocket. So tool will process the circular pocket layer by layer. Helical, I have explained in the previous topic. So helical means this will be like a spiral movement, spiral path or helical path. So the tool will move like a spiral or helical path. This will be very much useful to reduce the tool load. And processing mode. So processing position, we have processing will be roughing, finishing, edge finishing, and chamfering. So roughing, material will be removing very fastly. Finishing will be, this will give you smooth finish to the side walls and bottom. Edge finishing will be pocket side will finish the edge. There will be no bottom finishing, only edge finishing. So chamfering means if there is a bevel or chamfer, then in this circular pocket machining, that will create a chamfer. Then the plunging methods. Plunging method. So we have vertical plunging. So the tool pocket will directly enter into the workpiece. If we don't have a pre-drilled hole, very careful. If we don't have a pre-drilled hole, tool center cutting. Helical plunging, vertical plunging I have already mentioned, the tool will directly enter into the workpiece. Helical plunging means tool will follow a spiral path. So because of that, the entry will be very smooth, and because of this, tool load will be reduced. Then clearing options, complete processing. Complete processing means tool will remove complete solid material inside the pocket. Reworking means uh, ex currently there is a circular pocket. There is a drilled hole. So if we will select a reworking, it will it will enlarge that existing hole or that existing pocket. Okay, if you will be selecting a reworking, you should select A, Z, and phi 1. What will be the depth of the existing hole and what will be the diameter of the existing hole? If you will select this option, reworking option. Say, let's say take one simple example. Now you are going to create a pocket. Okay, so you say for example I'm selecting say 10 mm end mill. So feed say 250 per minute and spindle will be 2500 rpm, right? So pocket center will be x0 y0 z0 will be say 50 40 0. Okay, and the pocket diameter will be say 40 mm, and the pocket depth will be 8, and the processing will be roughing and finishing, right? So type will be helical. Okay, so dz will be 2, dxy will be 5, so uxy will be 0.2 and uz will be 0.1. So before doing the circular pocketing operation, make sure that the tool diameter will be smaller than the pocket diameter. Okay, so let's see this in our machine. Let's check this. Go to circular pocket, go to program manager, then click open. So click rectangular pocket and click mail. So next is pocket. Pocket selecting circular pocket. So select a tool. Number 5 I am selecting to program. Then say speed will be how much spinning speed will be say 250, right? Say 250 RPM. So, sorry, it's 250 feet, then 2500 will be RPM, 2500 RPM. Then machining will be first roughing, then assembly, then x0. What is the value of x0 y0? 50 40 0. Okay, so x0 will be 50 50 40 then 0. Okay, what will be the diameter of the hole? So the diameter of the hole will be say 40. The disadvantage is the absolute values you can give us 8. Then dxy will be how much? Say then dz will be dxy 0. So, so in circular pocketing, we have two modes. One is planar plunge mode. So, so one is planar plunge mode and a helical plunge mode. Okay. So in planar plunge mode, so the circular pocket will be machined uh, by removing material like a horizontal layer. Okay, one layer at a time. You understand? So tool will move to the workpiece, rapid traverse, and the retraction plane and safety distance. Then based on the selected strategy, it will enter into the material. In roughing, the tool will coming out of the center of the circular pocket and remove each plane or each layer like that. So this will continue till it will reaches Z1 depth. So till it reaches Z1. So till it reaches Z1, it will continue. So in finishing, first it will finish the pocket edge, and finally, uh, final in fit, it will remove material. It will finish the bottom center. So in edge finishing, it will finish the side edge only. There will be no bottom finishing. Finally, tool will uh, go to the its position in rapid traverse mode. Next is what is called a helical plunge mode. In helical plunge mode, the tool will move like a helical or spiral and then enter into the material. The main advantage of this is that this will reduce the tool load and we will get a smooth cutting. So in roughing operation, the tool will enter into the workpiece like a helical movement, top-down helical movement. Once once it will reaches the pocket depth, to remove the remaining material, it will follow a full circle. And finally, the tool will move to the safety distance from the pocket edge. So this process will uh, continue from inside to outside. In finishing operation, using the helical movement first, remove the pocket edge from bottom to till bottom finish. And after that, from outside to inside, it will finish the bottom spiral. Finally, from the pocket center, it will rapid traverse, move to the safety distance. In edge finishing, uh, using helical. Hello. So let's see this in machine. Rectangle. So next will be circular spigot. Okay, so this will be similar to the rectangular spigot. The only difference is the shape will be circular round boss or circular spigot. Again, the parameters will be tool, D, cutting number, feed, spindle speed, constant cutting speed, processing, reprocessing direction, X0, Y0, Z0, what will be the spigot diameter, then corner radius, alpha 0, Z1, then DZ, then DZ, then allowances in side allowances and bottom allowances. Okay, so let's see this in our machine. So next will be longitudinal slope. Next will be longitudinal slope. So here you can create a slope like this. That means like a groove or keyway. Again, the parameters will be similar to the previous one. Tool DFS reference point processing position for points, width, length. Then angle, slot rotation angle, then what will be the depth, Z1, then a step over, allowances, then feed, plunge feed, ankle, chamfer bevel width, chamfer tool tip plunge depth, etc. Let's see this in the machine. Slope, longitudinal, okay, this is longitudinal slope. This will be a circumferential slope. This will be like an open slope. Okay, so longitudinal slope will be so longitudinal slope is in the program. Okay, so zero, is a zero, width of the slope, length of the slope. Alpha 0, alpha 0 is equal to 0, right? Okay. Z1 will be at 6. Yes, 0.07 sometimes eventually it's too large. Okay. So we can do select circumferential slope. Okay, somebody is select the person to program. So simulation. Pricing നടക്കാണല്ലോ എന്തെങ്കിലും കട്ടറ വളരെ വലിയാണെന്ന് അവർ പറയുന്നു പറയുന്നത് Pricing കറക്റ്റായിട്ട് കിട്ടുന്നുണ്ട് എനിക്ക് മറ്റൊന്നും കിട്ടുന്നില്ല So open slot will be same, similar to the previous one. Next is technology options. Look at different types of milling, trochoidal milling, plunge milling. See, in trochoidal milling, tool will take circular movement. Then using that, it will cut the slot. So tool is taking a small radial engagement, so that tool load will be very less. Plunge milling. So plunge milling means vertical plunging movements. Coming to the next one, thread milling. In CNC milling machine, we can create thread, internal thread, using thread mill cutter. So the parameters will be mentioned here, similar to the previous parameters. Processing options will be two type, roughing, finishing. Processing direction will from Z0 to Z1, Z1 to Z0. Then thread direction will be either internal thread, right hand thread or left hand thread. From the thread table, we can choose the standard thread like isometric, width, VSP, UNC, etc. So from this table, we have mentioned this in the morning. So from the table, you can see the standard thread and its pitch values. In this table, we can see isometric, width, BSW, width, BSP, UNC. These are standard threads and their pitch values. For example, M8, the pitch will be 1.25 millimeter per revolution. Then internal thread and external thread. Internal thread means in milling machine, we will create thread inside the hole. Whereas external threading means like a shaft. We have a shaft or we have a circular boss. We will create thread is what is called external thread milling. And finally, we have our engraving. So engraving means, as shown in the figure, you can see, you can write letters on the surface, on the workpiece surface, or you can create symbols on the workpiece surface. For example, AIU, quite, okay, ABC, etc. So we can create letters or any uh, numbers or anything we can engrave on the top of the workpiece. Similar to the previous one, these are the parameters. Okay, so when you select the parameter, we have different alignments: linear alignment, curved alignment. Okay, so linear alignment means text will be on a straight line. Curved means text will follow a circular or curved path. Okay, so that's all about this session. So the next session will be contour milling. So we will see these options in the machine. Let's see. So next, we will see the full program. So next is tool programming. So tool management in CNC milling machine, we will be uh, controlling all the details of the tools is what is called tool management. Tool management means you will get all the informations about tool, its data, tool wear, magazine position, everything you can see and control it. Machine will select the correct tool and observe the tool wear and controlling the tool wear, tool magazine. So this, in tool management, we have mainly three lists. One is tool list, this one. So in tool management, we have tool list. So tool list means here you will get information about the tools, basic information such as tool name, tool number, tool type, diameter, tool length, corner radius, offset, tool geometry, tool status. So you can create a new tool, you can give a new geometry, right? You can edit tool, you can delete tool. Then tool wear. So tool wear means when the tool will working gradually, it will worn out, right? So here you can see length wear, radius wear, tool life wear, compensation, monitoring parameters. So the use is to give tool wear, adjust tool wear, give tool compensation, and also check the life of the tool. And the third one will be the magazine. So the tool will be in the magazine. For example, where is currently T1, T2, T3. Okay, so pocket 4 will be empty. In magazine, you can see the pocket number. Pocket inside pocket, you can see the tool. Okay, so tool number, tool status, tool change position. Then tool symbols. So if you see a red cross, so if there is a red cross, that means that is blocked. Okay, machine is not using that tool. Then if there is an yellow triangle down, that means it will be reaching tool wear limit. So we should change the tool. If you see this triangle, yellow triangle down means the next task is to change the tool. Then you have another one, yellow triangle up. That means tool is in special condition. You should place the cursor so that you will get the information. Then if there is a green frame, that means now now the machine is selected a tool that is represented as green frame. If you will see a green frame, that means now the tool is selected. Then double arrow. So this double arrow means, okay. So there is a double arrow. That means that tool now is in tool change position. That means now you can change the tool. Okay, if you see a double arrow, that means now the tool is in tool change position so that you can change the tool from the magazine to the spindle. If the red cross means magazine that blocked that pocket. Okay, so that pocket we will not be able to use. So if your tool magazine consisting of more number of tools, then we can use sorting function to sort the tools properly. There are three methods. One is according to magazine, according to name, and according to type. Then coming to the tool list. So in this tool list, you can see the tool. You can create. You can set up tool, all the information will be there. Okay, so each tool there is a unique number, unique tool number. So these are the tool list parameters. Okay, place means where is the current location of the tool in the pocket, machine pocket. Place number. Type means tool type. Type means tool type, and tool name. Okay, this is to identify tool. D represents the cutting number, and phi radius will be the tool radius, and phi will be the tool diameter. Tip angle or pitch, drill point angle or tap pitch. N is the number of teeth, and spindle direction, clockwise or anti-clockwise, and coolant 1 or 2, on or off setting. So before running a program, the suggestion is to open the tool list and check the tool diameter, tool radius, cutting number, spindle direction, coolant setting, magazine place, etc. If you set tool wrongly, then it will create machining size error, tool breakage, and a collision will happen. So there are two methods in tool management. One is non-random tool management. This is the commonly using method, and this is very easy to understand. So non-random tool management means every tool there is a position in the magazine pocket. Okay, fixed. There is a fixed magazine position, non-random. So once the tool will be used in the spindle, then it will go directly to the pocket, same pocket. So because of that, the tool name and the pocket number will be same every time. So pocket 1 will be T1 face mill, pocket 2 T2 end mill, pocket 3 T3 drill, pocket 4 T4 tap. So after completing the operation, it will go, these tools will go to that pocket. Okay. Then another one is called random tool management. So random tool management means this is more advanced in CNC machines. Okay. So during the operation, during the tool change, if there is a space, okay, so the tool available in the spindle will go to available space in the pocket. Okay, so for example, beginning pocket 1 tool will be T1, pocket 2 T2, and pocket 3 T3. Okay, so now the machine is using tool number 2. Okay, if you tool change T3, and what will happen is T2 will go to pocket number 3. There is no fixed position. So so during the tool change, the tool location will change. That is what is called a random tool management. So the advantage of random tool management will be tool change will be happening very fastly. There is no need to go to the old pocket. Okay. So if you program, do not look into the magazine pocket number. Only just look the tool number only. Okay, look tool number only. Don't look into the magazine number. So the program will be based on your tool number, not your magazine number. And another main thing is that when you when tool changing is happening, do not press the reset button, do not press the emergency stop, and also don't turn off the machine. If you during the tool changing, if you press the reset button, then sometimes collision will happen. We have to do re-referencing. Tool changer synchronization will be lost. So 3 things very important. During the tool changing, do not press the reset button, do not press the emergency, and do not turn off the machine. Okay, so do not press the reset button, do not press the emergency button, and do not turn off the machine. Next, I'm going to explain how you can create a new tool. Okay, so you can create a new tool by open the tool list, go to parameters and open the tool list, and after that you have to select an empty magazine pocket. Then press the new tool soft key. Then you can select the tool type: face mill, then end mill, drill, uh, chamfer tool, engraving tool, and after that give a unique name. Say for example, face mill underscore 50. So end mill 10, then drill 8, tap M8. Give a unique name. Then after that, give the tool parameters. What will be the diameter, then radius, corner radius, tip angle, number of teeth, tool length, spindle direction, coolant, uh, other geometry related aspects. After that, save this data. Now machine will add this tool into the tool database. Okay, so when you give the name, so make sure that name should be unique, and also the geometry, diameter, length, radius you should give properly. So do not use a magazine pocket number when you do the programming. Use only the tool name. Okay. Do not use the magazine pocket number, and also make sure that don't press reset or emergency button during the tool change. Next, create delete tool blades. A CNC tool is having more than one cutting edges or blades. For example, you can think about indexable face mill or turning tool. Okay, it is having more than one cutting blades. Okay, if one edge is worn out, you can use a new cutting edge. So you can create uh, each and every cutting edge, and also you can delete it in SHOPMILL very easily. So open the tool list, and select the edges, and then press the edges soft key, and then press the new cutting edge, and you can enter the consecutive. The new blade will be stored with consecutive numbering below the tool. Same way you can delete the edge also. Then non-random tool system. Okay, you have to select the tool. Okay, then press the delete tool. Press OK. Okay. If you press OK, then the tool will be deleted. In the random tool system, okay, one thing is that you have to select the tool. Okay, select the tool. If that tool is in the tool magazine, first unload it. Once you unload it, then delete soft key will be activated. Then after that, you can press the delete key. Then to confirm, just press OK. So if you press delete, then all the associated cutting edges blades will delete it. Next, how you can load tool. So open the tool list. Okay. Then from the tool pool, you can select the tool you need to load. And after that, manually you have to clamp into the spindle. And after that, press the load soft key. So you make sure that your pocket will be empty. Okay. Then if you load it, it will be go to the pocket. Before shifting the tool from the spindle to the pocket, make sure that that pocket will be free. Okay, so for example, you selected end mill of 10 mm diameter, then clamp to the spindle and press the load button. That's it. So you should create a tool in the tool database. Tool name should be unique. You should properly clamp your tool into the spindle. Once you clamp it, you have to press NC start. Based on the magazine pocket, or it will change based on the machine mode. If the tool is already in the tool pool, open the tool list. And then from the tool pool, select the required tool. Then manually clamp it to the spindle. Press the load soft key. If needed, load the tool into spindle or the available pocket. We can register that tool in the tool list and also in the magazine. Next, 3D tool. So what is the use of 3D tool? During the simulation time, you can see the 3D view of 3D geometry of the tool. And also you can give different color to different tools so that your simulation will be more clear to you. So open tool list and using the horizontal scroll bar, select the 3D tool column. 3D tool column. Then you have to select the cell, double click. Then a drop down menu will open. After that, you have to select the 3D tool model. Using the spacebar in the keyboard, you can select the tool. So what is the advantage of using this 3D tool? So simulation will be exactly similar to the real tool so that you can easily identify the tool collision. Tool length, shape, diameter, everything will be very clear. And also you will be able to identify programming errors. You can give proper color to the tool, right? So for example, end mill, you can give blue color, drill yellow, face mill green, thread mill red. So you can easily identify different tools. So select color and then select tool list using the horizontal scroll bar, select color selection and double click the color cell, and then you can use a basic color or you can use custom color. Next is tool wear. So tool wear means if you use a cutting tool long time, its length will reduced. This is what is called a tool wear. So because of reducing this length and radius, its measuring accuracy will be reduced. So we have to measure the tool wear and we have to enter this in the tool wear list. So control system will consider all those wear values and then make sure that the measuring will be correct. So length wear means once you used the tool, its length will be reduced. So you should give the correction value. So original tool length will be 100 mm. So wear will be 0.0002 mm. So its D length will be minus 0.02 mm. So control system will be using the new tool length 99.980. Similarly, radius wear. The original radius was 5, wear was 0.01. So the control will be using 4.990 only. Next will be the magazine. So magazine means all the tools will be stored in a particular place is what is called a magazine. Using the magazine list, we can see the information about each and every tool, and also we can control it. So we can see tool in which pocket. Okay, which pocket is free, which pocket is blocked, which pocket is empty. Okay, which pocket tool is in fixed position. We can control each and everything using this magazine option. If the magazine place is blocked, you cannot load a new tool into that pocket. It will show a red cross. Control system will avoid that pocket. Next, measuring a tool. So tool measurement means measuring the actual length and radius and enter into the control system is what is called a measuring tool. This is very important. Make sure that to ensure that the measurement accuracy is correct. Why tool measurement? If the machine knows the length and the radius, then the machine will be accurately carried out. So for that, we need a reference plane. We need a reference surface with the help of a reference block or workpiece or electrical tool probe. The surface is what is called a measuring plane. So tool measurement will be based on two methods. One is tool length measurement, scratch method. So tool will touch the reference block. So based on that surface, based on that surface, it will calculate the tool length. Tool radius, using the diameter reference surface. Using the electrical tool probe, machine will calculate the tool length automatically. That is what is called automatic tool length measurement. There is no need of manual adjustment. Using tool radius electrical probe, calculating the radius, automatic tool radius. We have to check whether the probe is in correct position or not. That is what is called a measuring probe alignment. To check the reference position of the machine is what is called a fixed point alignment. Tool measurement by hand. This is what is called operator will move the tool and touches the reference surface, and based on that enter the length and the radius. So scratch method will be like this. Place the reference block on the top of the machine table. So move the tool to slowly to the surface. Once the tool will touch the block, that same time save that length into the control system. Automatic tool measurement means install the tool probe, run the tool measurement cycle. Machine tool will touch the probe. So automatically tool length, radius, everything will be saved into the control. next session, I will discuss the what you call contour milling.